So I want to take a second to show you the repair manual for this particular model. The 805Y, YD, and again the 806 is the double check detector assemblies, the 825 are the reduced pressure 825YD. All use this same check mechanism on 4 through 10 inch. What did we just see with those lugs? And what it's telling me in the repair manual, it says this, and I want to read it. Seat disc removal, 4 through 10 inch. Caution, the new model 825 cast iron units have threaded disc holders with 4 cast lugs, 6 lugs on the 10 inch, half-inch high located on the back side outside the spring diameter. If the Model 825 you are servicing does not have these lugs, spring tension must be released by using the spring removal tool before further disassembly. Do not attempt to remove spring tension on older Model 825s without the use of this tool. So what the directions are talking about with the new ductile iron version, it's all stainless, it doesn't matter, but the older cast iron version, it's either going to have lugs like this or it's not going to have lugs like this. The lugs are telling us that the stem threads into the disc holder. No lugs tell us it's an uncontained, and as soon as I take that nut off, the spring tension is going to come out. Again, 4-inch double check, you can see I did it fairly easily by hand, but you can imagine if this was on an 825, the RP version, and it was the 10-inch first check, we'd have trouble taking that spring off by my hand. So let me show you how we're safely going to remove a spring out of this particular model, and use this logic for other models also. So how do we safely remove the spring when we have to? Now, for the average repair, replacing springs is not necessary, as we discussed earlier when we're talking about springs. But if you have to replace the spring, the key issue is safety, making sure we don't get hurt, damaged. Stopping a repair to run to the hospital is not a good idea. So using this example of the FebCo 825YD, again, which is a 4-inch version that we have here, the spring removal tool looks like this. It consists of these 2 pieces of all thread. People replacing springs in the 820, any model, always have to release that spring tension in a safe, controlled fashion. I've heard people say, oh, you just let the nut fly and let the spring fly out and go find the pieces later, or they stick it in a large vise, they put a forklift on top of it, all kinds of things that are not highly recommended. Proper way of removing the spring is with the proper tool. In this case, it's a spring removal tool. The tool I'm going to show you is fabricated by Febco. Febco will sell you this tool, but I can also tell you that Febco also gives you the dimensions to make this yourself. All the dimensions are shown in the repair manual. And as you can see, the first 2 parts of this tool are a very exotic thing called all thread. Obviously not very something we've all got floating around, hopefully. Anyway, so how does the spring removal tool work? First, there are 2 pieces of all thread on opposite sides of the body inserted. Once I have the all thread in, there is a flat steel bar that goes across these all thread pieces. You'll notice this tool is drilled for 4, 6, 8, and 10-inch style. The check body being larger as the valve gets bigger. But the center hole in the center stays over that bolt that's a spring retainer. So once I put that bar over my 2 pieces of all thread, I install 2 nuts on the all thread and tighten those nuts all the way down so that the spring tension is now pushing on the bar, not on the spring retainer. Once I have the nuts tightened down, I can go ahead with my ratchet, loosen that center bolt that holds the spring. That releases the spring tension off of the spring retainer and now puts the force on the back side of the bar. Once I have that off, now I loosen the 2 nuts on the all thread and I can safely release the spring tension. Again, much safer way, especially when you're dealing with the larger sizes, meaning 10-inch and stuff, that you don't have problems releasing that spring tension in a controlled fashion. This is the proper way to release the spring tension on a large assembly. This happens to be Febco, but you can see this can be used in basically any different model's configuration using the body, which was designed to hold that check assembly as your vise. So, if we have to release the spring tension, which we shouldn't for the average repair on the 4 through 10, but in case we do, we know how to do it safely now. Reinstalling the check assembly. Again, tightening our nut down, which holds the disc into the disc retainer. Making sure our seat's in good shape, our bushing in the center. Go ahead and install our check assembly like this, having it back in place. Bonnet and cover goes on top. Cover is sealed by an O-ring. The O-ring sits in the slot right here. Proper lubrication of the O-ring is critical. Test cock points to the top. That way we can also release air if we have to, when we turn the assembly back on. Go ahead and install your bolts all the way around the cover. And this is the check assembly on the 4 through 10 inch, as we have just seen in the 805Y or the 805YD. These are the same checks that we're going to see in the RP versions, which are going to be the model 825 and the 825YD. They did produce a double check detector assembly version of the 805Y and YD, and that's the 806 and the 806YD. And same story, same basic check construction, which we'll take apart and look at in a second. But they made a double check and a double check detector assembly version of their valve. And these are the same checks we're going to see in the RP versions of the 825 and 825YD. The next assembly we're going to discuss from FebCo is the model 825 and the 825D series, D for ductile, produced from about 1975 to about 88. It was produced in sizes 1.5 through 10 inch. The 1.5 and 2 were produced for a very short time, up till about 78, just about 2 or 3 years. But the 2.5 through 10 inch were produced for a much longer period, all the way up to 1988. In the original version, the non-D version, it was a cast iron body that was a painted epoxy coating. And towards the end of its life, they came up with a fused epoxy coating that appeared on some versions, and they switched to a ductile iron body, and that's what the D designation means. The rubber parts are the same for both versions of the check mechanisms, but there are some differences on the hardware parts. This is a reduced pressure principle backflow prevention assembly, so there's a relief valve mounted on the side of it, which is kind of hard to see in this picture as it's on the back side of the check valve, but the relief valve is mounted by a nipple on the back side, utilizes an external relief valve sensing line to attach the relief valve assembly. The same check mechanisms as we saw in the 805Y and YD version, with the 2.5 through 3 having the uncontained spring and the 4 through 10 inch having the contained spring assembly. The relief valve, as you see, mounted on the side of the body right here, mounts to the side of the check body. The relief valve utilized 2 rolling diaphragms in the center of that relief valve. Had one external relief valve sensing line attached to the body, and the relief valve was taken off of the body for the average repair. So let's go ahead and see what the model 825 and the 825D relief valve looks like. So when you're looking at the side of the body, what you'll see is this. This is the 825 relief valve. It is a double 2 rolling diaphragms that are in there. You can kind of tell by the thickness of the relief valve, as opposed to the newer 825YD, which most people are used to seeing. This is the older generation, the 825 series. So to rebuild it, I disconnect my relief valve sensing line, and I have to unscrew the entire relief valve from the check body and take it to my workbench for a proper repair. Once I have the relief valve assembly on the bench, now I want to go ahead and disassemble it. The first thing I have to remove is this nipple that I mentioned to you that attaches to the body. It's actually not just a nipple. This is also my relief valve seat. You'll notice on this side it has a regular pipe thread which attaches to the body, but once I pull that off, you'll notice that there is my seat for the relief valve. Once I pull this seat off, what I'm going to see inside is a bolt, and it's going to be very funny because it's got a hole drilled in the center of it. That's actually my low pressure sensing line for this particular design. High pressure sensing line is that 3/8 copper tubing on the outside, but my low pressure sensing line comes right through the center of that bolt. So the first thing I got to do is remove that bolt. Once I release that, there will be slight spring tension underneath, and that spring tension will now be released to the cover. But remove the assembly bolt first. Comes out like that. Once I have that out, now I can release the bolts on the body. And once I have this off, now I'm going to pull my upper body out, which exposes my relief valve spring and my relief valve stem. I'm going to push the relief valve stem out through the body, like that. At this point, I'm going to remove my relief valve spring, what's called my relief valve spring button. This is a real important part. What it does is it holds my relief valve spring, but more importantly, it keeps my spring from cutting into my rolling diaphragm. Now that I have that out, I'm going to fold my rolling diaphragm, top one in, and pull out what's called my relief valve spacer. It's a piece that holds the 2 bellaframs, but one very important point is this little breather hole right there, which we'll talk about on reassembly. Now, the 2 rolling diaphragms come out in one piece. The 2 rolling diaphragms are attached by 4 screws that you see here, and there's my relief valve cover. So to disassemble, I'm going to remove my 4 screws, place my new rolling diaphragm in place. There are 2 rolling diaphragms, and this, as I said, the first one has a hole in the center where my assembly bolt went all the way through. So what you're looking at without the body would be this. In other words, that assembly bolt holds that stem to that rolling diaphragm button. And as the diaphragm button moves back and forth, that's what controls my relief valve disc sealing on my relief valve stem, with the relief valve spring sitting in this location inside the body. So that's the movement that you would see of that mechanism if you could see through the relief valve body. Okay, as I said, this is what you should see, is the 4 screws with these blue plastic retainers holding the rolling diaphragm in place. There should be 2 rolling diaphragms in your repair kit, one with a hole in the center, the other without a hole, and that goes on the high pressure side. There's no hole for the bolt on this side. Some of the older versions of these plates offered some unusual things. This plastic is the commonly produced unit for the Backflow retainers, but the older versions had brass plates like this. They had a few different versions over the years. The first and oldest version of that relief valve button was a piece of aluminum. Febco used aluminum on several parts over the years. Remember we showed you that check cover, we showed you that spring retainer. Well, they also made the spring button for this particular assembly out of aluminum for a while. Now, when you go to retighten these 4 screws back on, one of the problems is that this has to be tight enough so that the water doesn't leak past here and go underneath that bolt. Because the way this is sitting inside the body is kind of like this. These 2 rolling diaphragms are rolling back and forth between this spacer. So my high pressure sensing line puts that high pressure on this side, my low pressure sensing line, which comes through my bolt, and you'll notice a counter bore right there, see up close right there, brings my low pressure sensing line through here. So the low pressure sensing line travels through the head of the bolt, comes out here, and loads the back side or the low pressure side of my elastic element. So what that means is there's high pressure on this side, low pressure on that side. This side's open to atmosphere. As this moves back and forth, these 2 diaphragms will breathe as they move back and forth. And if there wasn't an area for air to escape, it would lock it in. Back to my spacer. Remember that little hole I showed you right there? That's a breather hole. So when these 2 rolling diaphragms move back and forth, the breathing action will come out through that hole. The hole also serves another purpose because, as I started alluding to, when I tighten these 4 screws, it has to be tight enough to seal the water when it attaches. With the older versions, especially the aluminum ones, it was hard to get a seal on these little screws, especially when you were using the old brass covers like this. And what would happen is a lot of times the water would leak down through this hole, leak past the diaphragm, come out here and drip down my spacer. So if you saw water dripping out of that spacer through that breather hole, that would tell you you had a leak on your rolling diaphragm as it attached to the relief valve button. Light application of a silicone would hold that in place, kind of sealing it at that point. They then switched to a plastic material. The first generation was the blue color you see there, and the last color was this black color that you see with the plastic that they utilized. So you may have either type of those buttons that hold your 2 rolling diaphragms. The next problem we had with this was the stem assembly. The original stem is the white plastic that you see here, a plastic called Celcon, which had issues with expansion in size, meaning that temperature, meaning over-tightening could make it so that the outside diameter could actually change slightly. Now, in this body here, I haven't showed this to you yet, you'll notice there's an O-ring. And that O-ring sits right inside the body right there. The purpose of that O-ring is as this stem travels back and forth, it seals that. We've seen the earlier designs of the other models where the O-ring was actually laid into the center of the stem. In this particular design, the O-ring, which sits inside the body, sits right there, and the stem would travel back across it. So the stems that moved back and forth, but the O-ring stayed stationary. So when we repair it, obviously we change this O-ring. But back to this stem. One of the problems became is that the plastic would swell, and if the plastic swelled, now it would not travel easily up and down across that O-ring. And if there was a restriction on the travel across that O-ring where it was very hard like that, your relief valve's opening point would drop dramatically. So to help movement of that stem across that O-ring, it was critical that the stem be in good shape, and this was a part that was replaced rather frequently. The original version, like you see, or last version also, was the solid stem, just like this. Some of the other versions you might have seen is they tried a hollow stem for a while, thinking that maybe by having less mass it would not swell as much. They tried that for a while. They went to a harder plastic. They went from a Celcon to a glass-filled Naril style of plastic that was harder, thinking that the expansion wouldn't happen as much and more dimensionally stable. They went hollow at first, but they still had problems, so they tried putting a washer in to maintain the stability a little bit through its travel. They finally decided to keep the original one they had that showed the best properties of that particular design. So you may see any of those versions that were out there, but that's the one that was produced until production was discontinued, was the solid stem like that. Now, reassembling is going to be just the reverse. We have our rolling diaphragms that have been attached to our button. So again, here's the side with no hole on it. That's going to go on the high pressure side. We're going to put that onto the body like this, pull our low pressure rolling diaphragm. And the rolling diaphragms are directional. In other words, there will be a side right here that'll say button side. The button side means that the rolling diaphragm has to go against the button. So installing rolling diaphragm in place. Now my spacer. You want to make it so that the breather hole is pointing at the bottom or the discharge of that relief valve. So I'm going to put the breather hole down here. I'm going to go ahead and install my spacer. Once I have my spacer in place, like this, roll my second rolling diaphragm down. Now I'm going to get my spring button, my relief valve spring. I'm going to go ahead and attach my relief valve body like this. At this point, I have to have my stem, remember, inside this here. So I change the O-ring inside the body, insert the stem back through here. Ready to go back on the body like this. Go ahead and line up my bolts on the cover. It's a good idea to tighten these down by hand. Tight at first. And then I have to balance that stem through the center, and then I'm going to be inserting this bolt right through there. So I have to go through the bolt and catch that hole in the bottom. So by tightening these bolts down here hand tight, I'm putting it back together. So if I put it back together correctly, that bolt should drop right in, catch just like that. Go ahead and tighten it. Now, we fix backflow assemblies all the time, and we always wonder how tight should I make it, and we always say tight enough. This is the one time I will give you a torque dimension for a bolt. This particular bolt on this relief valve stem has to be 12 inch-pounds, not foot-pounds, inch-pounds. Does anybody know what an inch-pound is? Just about like that. That bolt has to be in there as an assembly bolt, not necessarily for a water seal. So it has to be very, very light when you attach it, because if you over tighten it, what you're doing when you go to tighten that stem is you're compressing this against the button, just like this. And the tighter you make it, you're actually expanding that relief valve stem out, and it will not work. So remember, very light, 12 inch-pounds is the actual factory torque. Relief valve seat back on. Now we screw the whole relief valve assembly back onto our check assemblies, reattach our high pressure sensing line. That's our model 825. The next assembly we're going to discuss is the FebCO model 825Y and the 825YR, which is a reduced pressure principle backflow prevention assembly. Production began around 1978-ish and is still in production today as we speak. 825Y, the R, again, letters meaning some different things inside the assembly. When you saw the R designation, it means it had replaceable check seats, because the original 825, when it was first produced, did not have replaceable check seats. So the R designation meant it had replaceable check seats, although its replaceable check seats became standard around 2007 when FebCO wanted to make their assembly with replaceable check seats. Replaceable relief valve seats were incorporated into the design about 1998 or 9-ish, when they went to a design where the relief valve seat was except the 1 1/4, 1989, excuse me, when all the relief valves except the 1 1/4 had a replaceable relief valve seat. So 825Y and 825YR. Here's our relief valve cover, inlet outlet shutoffs. First check, second check pointing down, first check pointing up, just like that. And here's what a breakdown of the assembly looked like. Here's our relief valve cover, relief valve diaphragm, which goes into our relief valve stem going into the body here. First check, second check down here, inlet outlet shutoffs, kind of showing you there's the replaceable relief valve seat, just giving you an idea what it looks like in a cutaway version. Let's go ahead and see what the assembly looks like in person. So let's go ahead and take a look at our cutaway and see what it looks like inside. Check mechanisms we're not going to go through because we've seen this in the 805Y series already, that angle pattern, Y pattern, poppet style check. Taking a look at the relief valve in our cutaway. Obviously the top half of my relief valve is gone, but what you will see are on the small one 4 or 6 on the larger size bolts that hold the relief valve cover to the check body. Once I remove the relief valve cover, it's going to show our relief valve diaphragm, again a cutaway version, relief valve stem like this, and the relief valve seat which sits in here. Again, the relief valve seat on the 3/4, 1, 1.5, and 2-inch was replaceable after about mid-70s. But on the 1.25-inch, the relief valve seat was never a replaceable unit. To replace the relief valve seat, you have to remove the relief valve body, which is held on by 2 Allen head screws. Remove this white plastic piece called a diffuser, and it allows you to unscrew the relief valve seat with a socket at that point. You can tell if you have a replaceable relief valve seat by looking on the bottom. If you see the seat cast in the body like this one, the relief valve seat is not replaceable. If it's a replaceable relief valve seat, you'll see a hex shape around the seat, which shows a way of attaching the socket to it. Now, talking earlier about high pressure and low pressure sensing lines, it's important to know where our high pressure sensing line comes in through right here on this particular valve, which goes through our relief valve diaphragm right there, through our relief valve cover, transferring pressure to the high pressure relief valve sensing line. The low pressure sensing line comes through the body right about here. So the low pressure comes in the center of the body. So high pressure comes from the cover on the outside, low pressure through the internal side of the body itself. Let's go ahead and take a look at the relief valve stem. I've got a 2-inch one here, which is a little bigger and easier to see. One screw holds the disc into the disc holder. Turn it over. Second screw releases the relief valve spring tension. This is another example of the O-ring stem design of relief valve. We have our spring retainer, our spring, our stationary spacer. With our mounting O-ring, our relief valve stem, and the O-ring in the center of the stem. How it works: O-ring stem design. The O-ring has a stem. The stem has an O-ring in the center, and it travels back and forth across that stationary spacer as the diaphragm moves back and forth. And again, utilizing a black rubber O-ring. We know the trouble with the black rubber is the black rubber reacts. The reaction is usually a swelling. The swelling can be from temperature or chemicals, something like chloramines. If that O-ring swells, you can see it's going to restrict the movement of that stem, which is going to cause problems on your relief valve opening point. There's that stationary spacer O-ring, which attaches to the stationary spacer. Reassembly is going to be just the reverse. Going to tighten that screw down onto the spring retainer, making sure we have it fully compressed and retained in the stem assembly. Replacing our relief valve disc underneath here. We tighten our relief valve disc. Now, ready to go back into the body. We'll use our 3/4 to put it back together. Here's what the stem assembly looks like. Making sure that the stationary spacer O-ring is properly lubricated is critical, because we have to insert it in here. And as you can see, we don't have the advantage of a cutaway when we're in the field repairing it. So what you want to do is put it in place, and when you stroke it once, what that'll do is set that stationary spacer this O-ring right there. That guide stays there. That O-ring gets set when I push it back and forth. As I stroke the stem in and out, I want to listen, because I should not hear any grinding or any galling action as I'm moving the stem, and it should move relatively easily just like that. The only trouble is you don't have the advantage of the cutaway like we do in this picture. Reassembling the relief valve diaphragm, making sure we have the opening hole for our relief valve sensing line. Cover goes on. This is our 825Y in sizes 3/4 through 2-inch. The next assembly we want to discuss is the FebCo 825YA and the YAR, which is a version of the model 825Y. In fact, the internal repair parts are exactly the same. Production began about 1989 and is still in production today as we speak. The R, meaning the same story with the replaceable check seats on this particular assembly. The YA did not have replaceable check seats, YAR did. Again, around 2007, the replaceable seat became the standard version. But what was unique about the YA was the end configuration of the assembly. In other words, the outlet and the inlet of the backflow assembly had a 2-bolt flange, kind of like a meter flange. And it was able to be adapted so that it could have an up and down piping orientation instead of being the horizontal piping configuration like in the 825Y. Those 2 flanges could also be manipulated to give some different orientations. Here's one where the inlet came from the bottom, and the discharge out of the number 2 check went out horizontal. Or you could have it so that the inlet came in on the horizontal and the discharge went out on the vertical. Or you could even make it a horizontal configuration with both of them piped this way. So the 825YA was designed with the 825Y check parts and relief valve parts to be exactly the same, but what was unique was the end configurations where it had an outlet flange so that the piping orientation could allow some different installation orientations. And that's the Model 825YA and the YAR, which had the replaceable check seats. The next assembly we're going to discuss is the Febco Model 825YD. Production began around 1989. It's a reduced pressure principal assembly. Utilizes the same check construction as the Model 805YD. Obviously different spring loads will be in the RP version, but same basic construction, the ductile iron body with the fused epoxy coated with the stainless steel internal checks. Here's a picture of what the assembly looked like. Relief valve mounted on the side of the check body, utilizing an external relief valve sensing line. Check covers pointing up at an angle from on the top. The check construction is the same as we saw in the 805Y and YD series, where the 2.5 through 3 inch have an uncontained check spring, meaning that when the cover comes off, the spring will come out. And the 4 through 10 inch have a contained spring check assembly. Here's an exploded view of that check, showing it how it's contained when the cover comes off of the assembly. The relief valve is attached by a nipple on the side. Does not have to be removed from the body for the average repair. Just removing the cover, you can take the guts out and rebuild it. Relief valve sensing line for the high pressure sensing line is external. Here's an exploded view of the relief valve. Here's our cover, our large rolling diaphragm, our stem assembly, and here's the breakdown of the stem assembly up here. Our relief valve body with our captured relief valve seat mounting O-ring. The stem assembly contains a spring, an inner rolling diaphragm, a stationary spacer, relief valve stem, and our relief valve disc. So this is what the relief valve looks like in its exploded view. Well, let's talk about the relief valve for the Model 825YD. This is what the relief valve looks like. It stays attached to the check body, or it is attached to the check body by a nipple like this. It can stay attached for the average repair. The whole relief valve body does not have to be removed. Relief valve sensing line is attached by an external high pressure sensing line, external copper tubing on the outside here. So once you go to repair this, what we're going to do is remove the relief valve cover. But the first thing I want to show you is right here where it shows this Febco 825Y. What is that? Well, again, this is a relief valve and it fits sizes 2.5 through 10 inch. And this is for the Model 825YD. Scenario is somebody walks up and sees this on the side of the backflow assembly and calls up and says, hey, it's on an 8-inch check. It must be an 8-inch Febco 825Y. Yeah, I need parts for an 8-inch 825Y. This is not a model number, this is a casting number. The 825Y we've already done, that only comes in sizes 3/4 through 2 inch. So what Febco did is they used this as a casting number, this Y designation, to separate the 825YD relief valve from the previous 825 relief valve, the one with the two bellaframs that we already took apart. So here's a case where the engineers used the casting designation for their molds and everything, but you can tell it kind of a problem because it came into conflict with model number designations they used on whole assemblies. So they have since removed these casting letters off of the assembly, and those are no longer on there. But many of the older ones you'll see where it has Febco and then it'll say 825Y. And again, that's just a casting for the relief valve, not a model number for the whole backflow assembly. Removing relief valve cover bolts will expose our rolling diaphragm underneath. Underneath our rolling diaphragm, we're going to see two very important things. One is, this little white tab right here that's going to come off. And the second thing is these directions that we're going to see right here. And what does it tell us? Do not twist assembly. Push straight in. Then it says to remove screw, cut tab and lift center circle. It's telling us two different things. One, do not do this. We don't want to twist that relief valve stem assembly in there. And then the second thing it's telling us is to remove screw, cut tab. Well, there's this little plastic tab that sits right here. It's held by a small piece, pull it off, and it exposes a screw on the top here. Why is this little plastic piece over the screw? Well, what sits on top of that screw is our rolling diaphragm. And if that little plastic protector was not sitting on top of that screw, you can see where the screw would cut right through the rolling diaphragm. So that's what the purpose of that is. Now, back to the problem. Do not twist. Normal reaction would be to pull it like this to get it out, but what you want to do is get your hands on both sides, opposite, moving it up and down, wiggle, and then the stem will come out in one piece, just like this. The relief valve seat is in the back right here. Does not have to be removed for the average repair. If the relief valve seat does have to be removed, you can see there's a 4-bolt flange on the back of the relief valve body. Just inspect the relief valve seat. If it's okay, check the bushing in the center. As long as those are okay, then you can leave the relief valve seat where it is. I said earlier the relief valve sensing line came through a tubing on the outside, which would be right here, and that's where your high pressure sensing line. Your low pressure sensing line is right there. See the hole in the side of the body? That's where our low pressure sensing line comes in. So it's hydraulically balanced relief valve. Let's go ahead and take a look at the relief valve stem and see why they cared so much, why we couldn't twist that. First thing we're going to do is remove our relief valve guide/disc retainer. Holds our relief valve disc into the relief valve stem. Once I've removed that, I'm going to turn it over. There's a second screw on top that I'm going to remove. Underneath it will be my relief valve spring tension. So hanging on to it, make sure you know you're going to release that relief valve spring just like that. Once that comes out, you have your relief valve spring. And this funny looking thing right here, rolling diaphragm on the inside, our stem, our stationary spacer, our lock nut, which holds the rolling diaphragm into the stationary spacer, friction washers, and our stationary spacer O-ring. So those are the parts of the relief valve stem. What is this rolling diaphragm for on the inside? Well, this is the revision, if you will, of the Model 825 relief valve. Remember the one with the two rolling diaphragms? The one that had a lot of trouble with the relief valve opening points always being excessively low? Well, the FebCO engineers wanted to come up with a way to make it so that those tolerances weren't so important on the stem O-ring design. Remember, it used to have the stem in the center, either in the center of the stem or in the body on the 825 series. So instead of having to worry about when this stem traveled back and forth and any swelling that may take place on that O-ring that was mounted in the center or the stem itself, the FebCO engineers decided to put a rolling diaphragm on the back side. So now you can see how loose those tolerances are on that stem. We don't have the problem of any swelling on an O-ring and or stem assembly causing a restriction of the movement of the relief valve stem. So that's what this is for. It's acting as a guide mechanism. It guides the relief valve travel through its stem, making sure it separates our low pressure sensing line, which would be putting the water, again, through that body right into this area. And the high pressure will be coming through the cover on this side. So it's hydraulically balanced, and this is to separate that low pressure, keeping so it doesn't travel along the stem and exit out the body. Okay, so those are the parts. That's how it works. Let's put it back together. We've seen several rolling diaphragms so far, and the key thing we always talk about with rolling diaphragms is how does the roll work. It's very important that it roll correctly. The rolling diaphragm is directional. It goes only one way. There is a roll on this side. If you look up close, you can see how it's rolled right there. On the back side, it's perfectly flat. Okay? In our stationary spacer, there is a recess. That's meant to hold the rolled section of that rolling diaphragm. So the flat section goes on top, and what's on the flat section is this friction washer, which sits in our lock nut. So that's what holds it in place. So the first thing we want to do is go ahead and put our rolling diaphragm in place. Go ahead and tighten that nut, hand tight, and hand tight's good enough. Remember, we've got the action of that O-ring underneath, making sure it's very tight. Once I have it in place, I want to roll it back up and start the rolling action just by hand, just like that. Now, the reason is because on the back side here, I want to get it past the lip on this stationary spacer. So I'm going to roll it up halfway. And once I get it halfway, I'm going to take my stem, inserting it in from the bottom with just a slight little rotating back and forth, wiggling it to get the shape of my rolling diaphragm. Center my hole with the stem and then go ahead and extend it. So what I've done now is I have rolled that rolling diaphragm underneath that lock washer. It's very, very important that we roll it underneath. Now, remember the directions we kept getting here. Do not twist assembly. The reason we don't want to twist that assembly is because anytime you twist a rolling diaphragm is you're shortening its travel length. Let me show you what I mean. I'm going to grab the top of this diaphragm and hold it, and I'm going to twist the bottom. And if I twist it, notice what happens. Anytime you twist it, you're going to shorten its travel. I'm not lifting up on it, but by twisting it, you're changing that height that it's going to travel at. So it's very important that we don't twist it, because if it's twisted in any way, it cannot travel its full length. So here's how we want that to operate, just like that. Relief valve spring, and our spring retainer. Pushing down on our spring retainer, catch our assembly bolt like that. Once we've got that, now we've got to be careful at this point, because our first reaction is, okay, I caught the bolt, I put it together, I got everything all ready. Not quite, because when I go to tighten this bolt, I want to be careful, because if I just sit there and tighten a screw like this, what did I just do? I just moved it a little bit, didn't I? Any of that small motion like that has the ability to twist that bellow frame if you're not careful. So when you get to that last turn of that screw, hang on to the spring retainer, the stem, and the stationary spacer like this, and then tighten the screw so nothing twists. The screw has to be very tight, because it is not an O-ring seal, it's actually a gasket seal on the back side of that diaphragm, so it's got to be very tight. If I twist that in any way like that, I'm going to twist that bellow frame, which is going to cause that relief valve to not work. Relief valve guide next. Stationary guide O-ring. Reinstalling my relief valve stem. You can see as you go to put this in place, it's a blind assembly. I cannot see the hole inside that relief valve. To kind of give you a little clue, is to help you, is to look through the relief valve discharge, because that way as you insert the stem, you can help catch the guide in the center so that you don't damage the parts inside there. Now, I haven't pushed it all the way in yet, because remember, when we stroke the O-ring stem, what's going to happen, it's going to load that O-ring right there. So when I go to push that in, I want to make sure that I first have it obviously properly lubricated, and then going in place, I want to make sure it's in perfectly straight. So have it in place. But before I go to stroke it, I want to be careful, because remember my directions, do not twist. If I just sit here on the edges and push inwards, it's possible that you twist it just slightly, not even noting it as you do it. Any twisting on that lower rolling diaphragm will cause a problem. So you want to take your thumbs on opposite sides of the screw, pushing in the center, push it up and down, load that O-ring on the stationary space, the guide, and that also makes sure that the relief valve stem operates properly. Put your small little tab back over the screw so it does not cut your rolling diaphragm on top. We're not out of the woods yet, because now I put my rolling diaphragm top one, the large rolling diaphragm on top, and what I can just do is just twist this to get it to line up the bolt holes, right? No, if I twist this, what did I just do underneath? I twisted that rolling diaphragm again. So when you go to put the rolling diaphragm, the large one on top, be very careful to line up the bolt holes. Do not twist it to line up the bolt holes. Once I've got my holes lined up, relief valve cover goes on next. Go ahead and get your relief valve cover bolts ready to go back together. Once you've rebuilt the relief valve assembly, go ahead and reattach your high pressure sensing line. And that's our relief valve from the FebCo 825YD. There is a model 826YD. Again, production began around '89, same time, in a reduced pressure detector assembly. So it utilizes the main valve similar to the R825YD, the bypass assembly. Here's a bypass meter, and the bypass assembly is an 825Y 3/4 inch as the bypass assembly. So 825YD reduced pressure, 826YD reduced pressure detector assembly from FebCo.